Stefan, you've shown us that it's actually possible to visualize things all the way down to the size of a single molecule using visible light. And I think the funny thing about this is that all the building blocks, so the knowledge of fluorophores, its chemistry and simulated emission, we had all of this for quite some time, but it really took you to bring all of this together. So could you maybe tell us a little bit about your process for thinking creatively about hard problems?
Indeed, it's true that many of the ingredients we've used to overcome the diffraction barrier in fluorescence microscopy have been around for many, many decades. And the question is, why did people not think about it? People think in terms of categories or boxes, if you like, and it's sometimes very hard to think out of the box. And it takes maybe a few people or one person at least that is challenging the box and asking, maybe this is just a box, maybe this is an overinterpretation, and then a new field begins.
I'm sure that there are many people out there who are working on such maverick problems and not on fashionable topics like AI or machine learning. And what do you think, and you're the director of institutes now, how do you think we can support such people?
Discoveries come usually as a surprise. And if you extrapolate current knowledge on the future, then you may end up with the predictive type of stuff. What we as scientists should aim at are paradigm changes that really make a big leap in knowledge. As a director of a basic research institute like a Max Planck Institute, we should be very sensitive to the mavericks that you mentioned, or to very unusual topics. And of course, many of those will be failures, because you never know what the outcome will be. You cannot predict a discovery. But you can kind of foster the probability that a discovery is made in the end. Research institutes should be aware of the fact that discoveries are not expected by definition.